And so I can introduce Matthew and Don. They're part of a company called Emergent 3D. They're based out of Reading, so I'm not sure if they're getting the same weather that we are. But they are using the 3D technology to build homes, most recently a new church, the first one in North America, and commercial spaces. And Matthew is the CEO, Don is the COO. Matthew has a lot of experience working with vulnerable populations, including working with FEMA-funded CAR Fire Disaster Case Management Program. And Don has been a contractor since 1990 and started his own company in 2004 and has a lot of experience with commercial and residential building. So I'm going to turn it over to them so that they can tell us more about the 3D technology. I know I am so excited to see the demonstration and learn more. And so thank you both so much for your time and for joining us. We really appreciate it.
Awesome. Thank you. It looks like Matt's taken over. Can everybody see Matt's screen there?
Yes, we can.
Okay, great. So yeah, again, thank you. First of all, Matt, I was going to say we need the cool backgrounds. We need to create an Emergent 3D background for our Zoom meetings. That really looks good.
That does.
Thanks for the idea. So again, my name is Don Ajamian. Pleasure being here. As Christina said, I've been a licensed contractor for about 32 years and been a resident up here in Northern California for about that same amount of time. And you know, have built structures, lots of houses, lots of, you know, affordable housing and commercial buildings and multifamily, and really ran a company that did work from Central California to Central Oregon at one point in the right in the 2001 range, was running, you know, about 120 employees spread out all over the 2 states, I would say. And those of you who are in the smaller towns, you'll appreciate this. Just when you're in a town for a long enough time, you get to know people in a lot of different ways. You know, the soccer parents, as I'm sitting on the sideline, you get to know the different parents in that way, and they happen to be maybe a building official or somebody in local politics or something. And that's kind of how it went for me. And so we had our car fire up here a few years ago, and because I've been around so long, I've gotten to know so many people. You know, after FEMA came in, you know, FEMA dropped off. They met with our community leadership and dropped off a notebook about 2 inches thick and said, "This is how communities like yours recover after such a devastating, you know, disaster." And so the Shasta County long-term recovery team was born, and I was asked to head up the construction subcommittee because FEMA had identified, you know, close to 300 families that lost their homes that were completely uninsured or severely underinsured and would have no way of rebuilding without help. And so that was the challenge of our subcommittee, of my subcommittee. And then that's where I met Matt. He was hired through a local nonprofit, NVCSS, and he ran the case management side of it. And so between Matt doing that and me doing my thing, and then all the other subcommittees, we met weekly for a couple of years addressing these issues. And needless to say, we got to know each other very well. And among many other things, I mean, well, one of the things we have in common, we both have 4 boys, and so we had lots of stories to share about that. But beyond that, he was telling me about this idea of 3D printing technology, and I was familiar with it just in that, you know, I've seen the little desktop 3D printers. I've done projects for architects who will 3D print this, you know, elaborate house, and it's kind of nice to be able to hold it and see it and get it in 3D, but this was something that was much bigger and actually using cement to build homes with, and I was quite skeptical at first, but hugely intrigued because it was addressing all of the pain points that I was dealing with at the time, and that I will say have only gotten worse in the last few years, and probably I'd say in the last decade. And the first one, like he has on there, is the construction labor. You know, I'm of the generation when I was in my, you know, teens and 20s, you know, we would go on to job sites, and there was a bunch of us looking for work. Nowadays, kids aren't of that age anyway, aren't looking for this type of work. It's been hard. It's been really hard to bring in the younger generation into construction. They all want to work with their thumbs, or they want to work on computers and write, do programming and things like that. So it's been tough. And a big part of it, Matt will talk a little more about this, it's a generational thing. There was just a whole lot more of us baby boomers than there are, this younger generation coming up. So I'm looking at this idea of this, automated process of requiring less labor. So that was of interest to me. And then secondly, this just the cost of construction in general. And a lot of that not only does stem from the shortage of labor, which is driving up the cost of labor just because of supply and demand, but materials have gone through the roof. Everybody knows the stories about lumber nowadays and steel and any metal products. Now with fuel where it is, it really drives up everything, because everything we get on a job site is trucked there from somewhere that came from somewhere else. And so again, this intrigued me because it requires a lot less material. When we 3D print a wall, we're not only creating the structure, but we are also creating the exterior finish and the interior finish. And so imagine all the materials that are eliminated in that one automated process. And so that too was quite intriguing. And then the last one that I was really, actually personally, probably almost maybe most excited about is this idea that, many of the affordable housing projects that I've ever been involved with, I'm sorry to say, they were quite boring projects. They're boxes, they're square, and it's by design. It's meant to be built affordably. It's meant to be very repetitive so that the crews can, gain efficiencies and you save cost in construction. And that was, by design, that's just how you do it. And the thing I liked about this technology is the computer system does not get more efficient by printing the same thing over and over. The computer system is going to follow the program no matter what it is. And so we can now create housing projects that are not only unique one to the next, but also very beautiful, because we don't, our machine, it'll actually print a radius corner much more easily than a 90-degree corner. So let's take advantage of it. It'll very easily do articulations in a wall, and that's something I could never affordably do anyway, using conventional sticks and wood framing. So we've got this whole new palette of design opportunities that was really intriguing to me. I mean, I've seen some pretty wild things, and the stupid joke I always tell is if we can get it through code, we can print your favorite pickup truck or kidney bean if that's how you want your house to look. And it's a joke, but seriously, like, we can do about anything as long as it can be designed in CAD and get through code. So so Matt, he intrigued me enough to get involved, and we presented this to our local building departments, and they told us all the reasons why this would be a challenge here in California. And as the old contractor, I'm thinking, see, I knew it. And good old Matt here, he just took that as his to-do list, and he went off and started checking items off one by one. And he came back to me and said, Don, I think we may have something here. And he showed me what he came up with, and we'll share it with you here in a minute. But I saw light at the end of that tunnel, and now I was hooked. So Matt and I joined forces, and we dove into that design along with our structural engineers and our architect, and came up with a house that we call it our wildfire restoration house. The plan was to use it for some car fire victims, and mostly down in Paradise for campfire victims down there. It's a 1,200 square foot, 3-bedroom, 2-bath, 3D printed house. And we did a presentation to the city of Reading, to the city of Reading, and it included the city manager, the assistant city manager, the building official, the fire marshal, and a few other people. And and we're telling them the story, and we're telling them how it could save cost and how it could be so beautiful, and here's what we can do. And we're telling them how, and you can be the first in California to have a 3D printed house on site. And our city manager, literally, he stood up, fists pumping in the air, said, yes, I want to be the first in California to have a 3D printed house. And our building official, this is no joke, our building official put his head in his hands, said, oh my gosh, I'm going to be asked to approve the first 3D printed house in California. Because if you've ever talked to those guys, whenever you ask them about something that's a little outside of the box, they want to know, where has it been done first? Who's done it? Show us how they've done it. And in this case, that wasn't there. But as I've said many times, the king spoke, and so they were all on board. And between our two structural engineers and the city actually even brought one of their structural engineers out of retirement to scrutinize these plans. So they had 3 of theirs and 2 of ours, and it went back and forth through plan check, I think 4 times. And we finally got what we believe to be the first on-site 3D printed house plan in the state. And that's it right there. That's actually the actual cover sheet of our approved plan. And it was approved as a master plan, and then that was used to then connect with the City of Reading Housing Division. And we've signed a contract with them to build 24 homes for various purposes in the City of Reading. Our main focus is disaster recovery, homelessness, and homelessness transitional housing, and affordable/workforce housing. And so that's what our program with the City of Reading is focusing on. And the first 2, we're printing this exact house in a couple of different city parks, and these are going to be park host houses, somebody to lock the gate at night and unlock it in the morning and make sure the riffraff isn't making trouble overnight. And the next project that we'll do is for it's for a 501c3 in town here, and it will be used for a at-risk population. Without getting into too much detail, it'll be used for this at-risk population. So it's going to be some housing for them. And the third one that I'm really most excited about, because the city is partnering with us in a big way, and so our commitment to them is we will provide all of these homes at our cost for their use. The third project, like I say, I'm most excited about, we get to design and build a group of homes for individual sale, and it is a challenge to see how inexpensively we can put those on the market for. And so we're thrilled. The challenge has gone out to our design team, to us as builders, to come up with something that is not only gorgeous, but is very reasonably priced as well. So we've ordered our printer. Our first printer shows up here, shipping delays aside, probably around mid-April, at which time I think by end of April, beginning of May, we'll start printing this very home that you see on the screen here, right up here in the City of Reading. So I think, Matt, at this point, maybe I'll turn it over to you, and I'm available to jump in if you need me. How's that?
That sounds good. Thank you. Wonderful, Don. Well, it's an honor to be here with you guys again. My name is Matthew Gile. I'm the founder and CEO of Emergent 3D. And so, as Don mentioned, the 3 main areas that we're initially wanting to serve within the housing market is the affordable housing market, disaster recovery, and workforce housing, or also transitional housing for homelessness recovery. So just the main areas that our entire state is grappling with right now. There's about 3.5 million new units that need to come online by 2025 in order to even make a dent in our affordable housing market, and so we're just not getting there. And so there needs to be something that changes that equation. For those of you that haven't seen a 3D printer, a commercial size 3D printer in action, let's take a look at this video together. So I would like to just underscore for those that may be familiar with, say, Mighty Buildings or other great companies in our state that are doing factory-built 3D printed houses. Ours is all on site. So the printer itself is larger than the home or the commercial building that we'll be printing. And as you can see, it just layers the walls up layer by layer, and we're printing in conventional concrete. So we are receiving the next generation printer from the top 3D printer manufacturer in the world, Cobot. And it used to be an expensive high performance mortar proprietary mix. In partnership with Cemex, one of the largest cement companies in the world, they came up with what they're calling their magic sauce, their secret sauce, to put additives into conventional concrete, and they're seeing about a 90% reduction in material costs as a result. So that we're very excited to be receiving that, and I think we'll be the second in the USA to receive that type of a printer. And then so let's take a look at the finished products of that. What you saw before was the job site. Now here is the house itself complete. This job or this project was completed in Germany using the same 3D printer that we'll be taking delivery of, but is the first 2-story single-family residence that a family will be moving into if they haven't moved in already. They intentionally left the walls as it came out of the printer. We are able to and will be playing with lots of different finishes, but notice like the rounded corners here and on the balcony. We will be, and with Dawn's craftsmanship, we're going to make these very desirable homes, and so we can smooth the walls, make them like a plaster wall type finish. But again, we want to point out some of the features, like as it comes around this tub surround, that rounded corner. Those are custom level finishes, but that are no additional cost with the 3D printer. And so, but if a family does like the aesthetic of how it was coming out of the printer, we can obviously leave it as is. Some of the solutions that 3D printing brings is when we anticipate, once we have our efficiencies down, to reduce the total cost of construction 35 to 40%. And so where is that savings coming from? We won't need to clad the walls with stucco or siding on the outside or drywall on the inside. We can do that, but obviously that drives the cost back up. What's coming out of the printing nozzle is the finished product, and we're going to be playing with different options, like a patch and stack type finish where it's nice and smooth, and then also the readily available materials like sand, gravel, water, and bags of cement that you can find at any Home Depot. And so again, why that make the ability to put additives in to make any locally sourced concrete and cement 3D printable was a game changer, and we're excited to introduce it to the California market. And then also a lot of people are saying, oh no, the robots are coming, you're going to steal everybody's jobs and you're going to automate and put people out of business. Actually, no. As Don had mentioned, we have a generational gap. So certainly my generation and the millennials are just not coming into the trades. And the baby boomer generation is the largest cohort of tradesmen and women. And the front half of their wave has come through since 2013 and have been retiring. And the last half of the wave is going to go and be retired out by 2030, taking their expertise and wealth of experience with them. And so for every 5 baby boomer generation tradesmen and women who retire, there's only 1 that is coming into the trades. So we're having a significant contraction of the labor pool. And so we need 200,000 brand new tradesmen and women to enter the California market, brand new, in order to meet current demands. And unless we have mass automation or mass immigration, we're just not going to be able to fill those numbers. And so what 3D printing does is allows that machine to plug at least a little bit of the gap of the labor shortage that we do have, and it maximizes the available labor that we have. For example, we're still going to be using wood trusses and drywall on the ceilings and stucco on the underside of the eaves there. So we still need those trades, but we can take a 4-person crew, and instead of having them all in one house, we can divide them in half and send them to each different job sites, so that we get a net result of more homes built more quickly and for cheaper. And so also construction is one of the most dangerous jobs in the world, I think, just behind working in a mine. And so job safety on the site will be, it will help to reduce workplace injuries. So we're excited about that. I needed to update this last line here, but we will be using a 3-person crew. And so one to be at the laptop, another to be feeding the printer the material, and then someone that is assisting both of them. And then also, as Don mentioned, the freedom to design. So in order to get our economies of scale, typically we've had to have that repetitive design. And so the 3D printer, as long as the architect can put it into CAD and it passes California building codes, then it can be 3D printed. And as we mentioned, we have one design that's been approved now and by City of Reading Building Department, Shasta County, Butte County. You anticipate to have Town of Paradise master plan approved here in the next couple of weeks, and then also here they're closer to you in Tuolumne County. And here's an example of what an affordable 3D printed house can look like in our communities. As you can see, they're anything but concrete bunkers. They're actually aesthetically pleasing. And then also here's another example of what an affordable 3D printed house could look like in our communities. I'd like to point out they're fire resistant because they're concrete. So here in fire country, having at least a little bit of peace of mind that you're going to have a more resilient home against wildfire is important. It also is 29% more efficient than the 2020 code requires. And so because we have an air gap rather than thermal bridging with studs and high performance insulation, we can, our model shows that our energy engineer, that it calced out at 29% more efficient than the code requires. So that will be very helpful for families who need to save on the energy bill. Some unique design features that I'd like to point out is notice the wavy wall by the front door. That's what we're calling our organic wall. And here's a better look at it on the angle. That would be totally cost prohibitive or nearly impossible to do with traditional methods of construction. But with 3D printing, it's just easy as hitting the spacebar button, and it will do it. And so also this cone-shaped pillar, again, that would be very difficult to build with conventional methods of construction, but with the 3D printer, it is no problem at all. And then these unique design features that are more of a what a custom level finish, the beveled and recessed windows and curves, and the floor to ceiling windows and doors. We did that design in order to remove having to print over the top of a door or window. We can do it, but with the cost savings that we're realizing, we figured let's just go ahead and put that in. It makes it easier to 3D print, and it's a more desirable look. And we went just with an open floor plan for this 3-bedroom, 2-bath. Some environmental benefits that come with 3D printing with additive manufacturing is that there will be less waste going into our county landfills. And why is that? When the 3D printer stops printing, the material stops. So we're going to have less offcuts of 2x4s and drywall and other materials going into the dumpster and then the dumpster into our landfills. And I thought this was a staggering statistic that 70% of all the waste from construction, from wood, drywall, bricks, and clay tiles, end up in our landfill. So I think at least we'll be able to reduce 3 of those 4 materials, which is also very good. Let's see here. And then we're also happy to announce that we're working on the first 3D printed church or commercial building in California, and the first 3D printed church in the world. And so if all goes well, we hope to have plans approved for this building by this summer and start on this project in the fall. But some design features I'd like to point out is you can notice again the wavy walls. The architect wanted to make something unique. And then on the inside, we're just really excited about this. We're able to, our architects reached out to a top acoustical engineer. I think he designed the Kennedy Center in DC. And if you'll notice the walls, how they look like curtains, and how they start a little bit thinner on the top and then they widen out. That is all not only architecturally beautiful, but it is acoustically tuning the room. So the architecture has a practical application with the acoustics. And so these are just type of features that we can add in with 3D printing without significant cost increase. And so we're really excited to see what other architects, and I'm glad to have an architect on with us to start dreaming of all the type of use cases and neat, unique designs. And so we've been busy developing a partnership ecosystem. As you know, to get these large scale projects off the ground, it takes a village. And so we've partnered with the city of Reading, but it's the government agencies and that both approved the projects. We had a 5-0 vote with the city of Reading City Council, we were really grateful for that, to approve the city of Reading project. But they also are able to provide government funding through, like the American Rescue Plan and the Community Development Block Grants and the Disaster Recovery Block Grant. And then also the private sector, like Emergent 3D, the for-profit companies and contractors and subcontractors and banks. And our business model is that we are a subcontractor. We will do the design and then also the 3D printing services, but we're wanting to partner with local general contractors so that the local trades benefit as a result, and we're being a value add to the local economy. And then the nonprofit sector, we're partnered with several housing nonprofits such as Access Home and Habitat for Humanity, Tuolumne County. But they're generally the ones that are the long-term property management companies or the landlords. They're also able to receive grants for government funded continuing care programs. They also can receive HUD funds like Access Home was able to do to make this project here in Reading get off the ground. And then also the education and skills training that the nonprofits we're partnered with CSU Chico that are raising up the next generation workforce. And so here's a look at some of our partners here in the North State. We are really grateful to Cornerstone Bank for providing the financing, and we're partnered with Cobod, the top 3D printer manufacturer in the world right now, both by the number of volume printers that they've sold, and for their printers have been used in real world projects that have where families have moved in. And then CSU Chico, we just recently signed as a employer signatory with the Labor International Union of North America. So we're wanting to bring union pay scale and benefits to these communities so those who are building the homes can also afford to live in them. And then we're honored to be partnered with Habitat for Humanity in Tuolumne County and also Access Home. And so if you'd like to get in contact with us, here's our contact information, my email address, and our office number. And I'll turn it back over to you. Thank you for having us.
Wow, well, thank you. That was a fantastic presentation. Your models are beautiful. I really appreciate how you really set out the problem for us and then the solutions. And there's quite a few questions in the chat. So we'll start with the first question from Sashay. Sashay was asking, Don, when you were talking about the FEMA solutions, she put this question in the chat and she was asking, can you speak to the treatment of this solution as FEMA response in temperature to permanent housing and ability to finance via federal resources or other allowable costs for individuals impacted by wildfire or other disaster?
Ooh, that's a mouthful. I might actually maybe
Sorry.
let Matt, that's okay. No, I'll let maybe Matt deal with that. He may be a little more familiar with that topic than I am.
Yeah, so go ahead.
No, I was just going to say, I really appreciate that you guys are working with the long-term recovery group. And I think recognizing all of the kind of engagement that you've done at the local advocacy level, but also figuring out sometimes those gaps between like real-time solutions and then what's actually allowable costs from FEMA at the time of disaster. So would love to zoom in on that. Thanks, guys.
Yeah.
Absolutely. Well, thank you for your question. And I hope, so just let me know if I'm not addressing it. But since I served as the program manager for the disaster case management program here for the Carr Fire that was FEMA funded, the way that it went for folks here is if they were awarded a grant, then they could apply that to their homes. And most of our clients, unfortunately, were so severely underinsured that they still, even with the FEMA grants, weren't able to make make up that gap. And so what our long-term recovery group ended up doing is through donations from very generous donors and through the nonprofits in the county and city grants, we're able to gap that funding. Unfortunately, right now with where prices are going, that gap has only grown. And so that is what we're hoping that this technology will help to address, is at least bridge that gap more. If once we get to the 35 to 40% savings, right now we're not until we get our efficiencies down, but moving forward, we're hoping to close that gap. And so to make these homes affordable where wildfire recovery clients can afford it.
Thanks, guys. Beautiful stuff.
Thank you.
Thank you.
Yeah, we're excited to take a road trip to Reading to see your community.
You're most welcome.
Oh, thank you. So we'll continue with the questions in the chat box. If you haven't had a chance to ask your question, you can raise your hand once we're through with the chat box questions, or you can add your questions to the chat box. So Ty just made a comment earlier when you were talking about the loss of labor force because just not enough people are going into the trades like they used to. She put the comment in that I also read that basically 3D homes manufacture that which is already manufactured. So in that way, it couldn't arguably extract from jobs. So thanks for that comment. And then the next question is, what about earthquakes? You were talking a lot about the homes being resistant to disaster or to fire. How do they hold up to earthquakes?
Yeah, so actually, I'm going to maybe just comment on the previous one.
Sure.
To be clear that we are not looking at this as a replacement for manufactured homes. There are companies doing 3D printed homes as a manufactured home in a factory. And the challenge with that is that you can only print something that's as wide as the highway lane to deliver it where you're going. Ours is actually an on-site solution. We set up the machine on the property, on site, and this first machine that we've ordered can do, it has up to a 3,000 square foot print area. So we can do much bigger and broader shapes. So I do appreciate the thought that it's maybe just trading one for another, but it's more competing, and this is an important factor also, being that we're doing it on site, we're actually doing in-ground foundations and all the rest, it qualifies for traditional financing as well. So, and then regarding the earthquake question, it's a great question, and that was really my first hesitation about even getting involved in this, is California has quite a history. You know, many years ago, or very early in my career, that there were a lot of unreinforced concrete, unreinforced masonry buildings that came crashing down in earthquakes, and so it changed codes, you know, in my younger years. And so there is a great deal of testing happening as we speak by companies with much deeper pockets than Matt and I, and they will get this through at some point eventually. In the meantime, while they're doing their thing, we wanted to start building homes. And so we created a design that can work through with the current laws that are on the books, right through the current code. And so our design actually utilizes post and beam construction. So within the exterior walls, if you saw it in the pictures, if you didn't notice, in every wall, we actually print 2 extrusions. Think of it like we're printing the skin of the walls. And on the exterior, we're printing the exterior skin and the interior skin. And there's a 10-inch gap. Well, within that 10-inch gap, we also print some intersecting lines to create a 10-inch by 10-inch column void that after we're done printing, we drop a rebar cage into it, secure it to the foundation, and fill that full of concrete. And we do that about every 8 feet on center around the perimeter of the house, and that becomes our posts. And that is a code acceptable method. It's you know, it's, as I said, it's been approved per the California Building Code. And so the walls themselves, the printed walls for now are just the skin, but the whole thing is being supported by these columns that are steel reinforced.
So I'm going to jump ahead, just kind of piggyback on that with a couple of questions, I guess.
Yeah.
So one is Tara's question about how about strength and durability over time, and then just speaking to the concrete. Philippa, and I apologize if I'm mispronouncing your name. Concrete is a very unfriendly material, creating environmental concerns. What are you doing to mitigate this? And then one third question, if you can keep that all together, is that you had mentioned that you qualify for financing like you do with a traditional home. But when Matt and I were speaking a couple of weeks ago, we touched a little bit on the fire insurance coverage and how because these homes are resistant to fire and made of concrete, you actually are better off qualifying for that. So maybe you could touch a little bit too on the insurance piece as well.
Well, Matt, maybe I'll take
that was a mouthful.
Yeah, no, that's good. I'll take the first one, and he's younger than me. He'll remember the next 2.
Okay.
On the first one, you know, it's concrete. At the end of the day, this is concrete. There are lots of concrete structures that have lasted a whole lot longer than homes that have siding on them and other more traditional methods. So we're not really reinventing, you know, the wheel. We are just reinventing how it's applied. So at the end of the day, it's a concrete structure that you know, we can all drive around and see different concrete structures that really last much longer than conventionally built homes would. And then regarding the environmental and the insurance, Matt, I'll pass that one on to you.
Yeah, those are wonderful questions. So we are in it. So it's true that cement is, I think it accounts for 8% of the total carbon footprint globally. And so we are in discussions. There is a new company that Forterra that is come up with a limestone-based cement process that they are able to reduce their carbon emissions footprint by 60 to 80%. And so we're hoping to see if we can incorporate them and use their mix as a part of our 3D printing material. And so and there are others that are trying to work on that. And so that is going to be forthcoming. The material science is just going to continue to get better and better. as more come into this market. And so as of right now, we don't have stats on the total amount that it's less, but if you just think that we're reducing a lot of the other externalities like delivery of materials and trucks coming and going and the like, everything is batched right there on site, and so I'd say an overall net it'd be less than a stick-built home, but we don't have data. It's still early on, but we are working to address that. That's very important to us. Secondarily, for the insurance question, especially with families who are in high fire area, certainly in our the clients that we were serving, some of them were rated as uninsurable, and their only option was the California Fair Plan, which was the state stepping in to try to provide options for families. And then it only came with 2 perils, and that was with fire and flood. They usually, on average, would have to pay 3 to 4 times more for just those 2 perils versus their neighbor down the street that was rated insurable and then could get all the perils and then be less money. So we're wanting to and starting to do preliminary outreach to the government, for the California Fair Plan, to see if they'd like to take a look at our home. And it would help to de-risk them, and then also other insurance companies to show that, well, this is a concrete home, so it's going to be less of a risk. And so we're working on that as well. So hoping to reduce our carbon footprint, but also get a much more affordable, get folks insurance plans that they can get coverage and reduce the cost for them as well.
Great, thank you. And then just to follow up on the concrete, in addition to using the mix with limestone, are you able to use other materials like a hempcrete or earthen block or in the printing machines?
Yeah, so that's the exciting thing is we're just right at the very beginning of this industry. And so we are looking at hempcrete as a potential. Right now, we're just trying to get job 1 going and getting all that perfected. But some of the things that I've read about hempcrete is that it actually sequesters CO2 out of the air. So and with those fibers is even more durable. So we will definitely be exploring all of that in the future. So.
Sorry, I'm scrolling up to see the rest of the questions. Okay. So Stacy, our CEO, had to leave early, but she plans to watch the recording, and she had a few questions for you. The first one is, I'm curious about how these solutions scale over the next decade to alleviate the current needs in California. Our second question is, what are the biggest barriers to this idea? And our third question is, if you had a magic wand to help this scale, what would you do?
Oh man. Tell me, what was the first one again?
Sure. It was how do you see these solutions scaling over the next decade to alleviate that 3.5 million units needed in California?
Yeah, so on the scaling side, you know, again, one of the things I like about it is that we can do more with less. And you know, as we said, one of the big limited resources we've got is manpower, and the other limited resource is money. And so if we can do it with fewer people and less money, the output could be more homes. And so the scalability is built into the technology. And with this type of technology, I mean, think of our flat screen TVs. You know, 10 years ago, you know, a TV that was $3,000 you can buy for $279 at Walmart now. So that's this technology. It's only going to get less expensive and much better and more efficient as we go. So I think the scaling is built into the technology itself. In my mind, one of the biggest barriers is in the material. The temperature, the humidity, the different environments that we're in all have an effect on our materials. And I would say even throughout a given day, up here in Reading, it can get quite hot, but if it starts out at 70 degrees and gets up to 110, you've got to modify your mix as the day goes on just to keep printing. And so that's the biggest barrier that I see, quite frankly. I mean, I think people will get used to the look. Somebody asked about the modern look. People will get used to the look, and many more designs will come out, more traditional looking designs, and all that, those can be addressed. But if we can't tackle the material issue, and I am so looking forward to the hempcrete. I'm looking forward to, like, how many things have we gotten from the space industry? And you'll understand why I'm asking you that. Like Velcro is a good example, right? NASA is working with another manufacturer right now to do 3D printing on the moon. And they are not going to take up thousands of gallons of water and piles of sand and gravel and bags of cement to the moon. They're going to use whatever they can find locally and somehow with their NASA magic print buildings. That technology will come back to Earth, which, you know what, they can have the moon, I'll take Earth. If they can figure out how I can grab the dirt and the sand around us and make homes out of it that people can live in and they're safe and effective, that's a dream come true. And so this exponential technology is, for me, it's quite exciting to be a part of. I'm glad to just be a small part of it. And for me, my magic wand, and sorry about this, but we've had so much demand and there is so much need that we need people and we need money. We need as many people to get involved in this story as possible, not just on the private sector, but we need public sector, we need the nonprofits, and we need funding. Now, we know California's got a lot of money set aside for workforce housing, for homelessness transition. We need those grant writers who know how to get a hold of it and come up with projects. And we can show the state how to solve a problem, I believe.
Yeah, and for scaling, that's also one of the chief reasons, amongst others, is why we partnered with the labor union. Is they have a network across California, and they will be able to help us recruit and train new employees from across the state. And so being able to tap into that network and then paying, again, high-paying, high wages and benefits. And so that benefits all the communities. And so right now we're just, as I mentioned before the call, you asked how are we gonna, we have one printer coming, how are we gonna do this? We anticipate probably have to, and I think there was something about through the decade, we anticipate having to, if all goes well, about 100 printers, deploy 100 printers across California. And so that's what we're trying to do our part to deliver as many as we can and start reducing that 3.5 million home number with deliveries.
So we have about 7 more minutes, and there are a couple more questions in the chat. And I also have a question. How does this scale to single homes, one-off homes, and not a community of homes? Is that possible and feasible at this time?
It certainly is. In any case, we've got to set up our equipment and then take it down and move on. And I would say the biggest difference between a one-off is just the design expense. If it happens to be a design that's in our library, then that one-off doesn't incur the expense of the design. Aside from that, for now, we're looking for flat property. If it's a home that can be built with a slab on grade, then it's for us. If it's on a slope, at least for now, it's probably not for this technology. But absolutely, as long as there's room to set up the equipment and we can get over the design side of things, absolutely, we can do a one-off.
Thank you for bringing up those conditions.
Yeah.
It's very specific to our region. And so I know, can you build multi-storied, multi-unit buildings?
Yes, we are actually just received a letter of intent for a 430 unit project. It's a 4 apartment complex and townhouses. And so with this larger printer, and I failed to mention that it can do a 3,000 square foot single story within its print area, or a 6,000 square foot. They're also coming out with the next generation which will be able to retrofit our model here that you see on the screen to be put on rails. And so that will be very cost effective and time efficient for a multifamily and 2-story is what. So we will be going up and down, setting it, and then it would just be along tracks. And so we absolutely want to serve the multifamily market.
Great, thank you. And then another question related to earthquakes. Is there X bracing in the walls? Post and beam doesn't address the sideways loads of earthquakes. And what about our heavy snow loads, especially over the windows?
Yeah, so there is not X bracing. And actually, as long as it's, and I'm not an engineer, so I may not get it exactly right, but it's, I think they call it a cantilevered column. It's a column that's tied into the foundation. And so it actually does address the shear because of the size of the column. And then what we've got is, so if you could imagine it, you got a foundation and you've got a column that's tied to that foundation. And at the top of all of these columns is a continuous beam that ties the top of all of them together. And so depending on the snow load, depending on the location, the size of the footing, the size of that column, and the size of that beam can all be adjusted based upon whatever the load conditions are in a certain geographic area. And then we're using conventional trusses, so certainly those can be designed as necessary as well.
Did that answer the question for you, Christy? See you nodding, yes, okay.
Cool. I knew that was your question, Christy.
Great. Does anybody else have any additional questions for Don or Matt? You can throw them in the chat, you can raise your hand. I know Tara had a few in the chat box. I think you can address some of them. She told me I didn't have to ask all of them. But are there any particular concerns regarding electric, plumbing, etc., that are different from regular homes?
That's a great question, actually. So as I said before, every wall that we print, interior or exterior, we're actually printing 2 courses. We're leaving a gap in the middle. If it's a plumbing wall, we leave a little bigger gap. If it's not a plumbing wall, we just leave a smaller gap so we can run electrical in that gap. And in the exterior, it's a big enough gap to not only allow for our structural columns, but also the insulation that will blow into the cavity. And so every trade is affected a little bit, right? We've got to retrain our electricians because literally they would install their little blue boxes as the printer is coming around, right? When we get up to outlet height, they take, it almost looks like a cookie cutter. That's the shape of their blue box. And they just kind of cookie cut out little concrete, put the box in, and the next layer goes right over the top of it. Plumbing is a little different. Hanging doors and windows, a little different. So there is some retraining of our current crews, but from all of our indications, we've had some really good buy-in from the subcontractors and suppliers.
Well, thank you for the wonderful presentation and answering our questions so thoroughly. We really appreciate your time and knowledge and expertise. And so I will just open it up one last time for any final questions. No? Okay. And then I'm going to do a little plug for our next 2 speakers for the speaker series. And we have one coming up next week, March 8th, with Gabby Velasco from the Urban Institute. She'll be talking to us about the intersection of housing and climate. And then the following week, March 14th, a little bit different from this one, we'll be talking about using mass timber to build homes with Megan Stringer of Homes and Lisa Gelflin of Gelflin Partner Architects. Lisa is based in the Bay Area and also has a place in Soda Springs. And so it'll be an interesting discussion on how and if we can use our forests to build sustainable homes. So we hope you can join us. I will send you an email, anyone who participated in this series, to follow up with Matthew and Don's information, a link to this recording, and then more information about our speaker series. So thank you again, everyone, for joining us, especially to Don and Matthew for your time. And we hope to see you guys soon.
Thank you for having us.